let's see the example on interface as a type. So I declare interface as an I person, and then I define a variable of type string. Then I define the age for the person, and this is a type number. Okay. And now I declare a variable is a p object, and it is a type of I person. And how to initialize it? So look here. So name colon. So this is suppose John. Here you define age colon. Suppose it's 25. Okay. So new variable is okay. So here I need a comma, and now suppose I want to just print the data console.log. Name of a person is equal to p object dot name, and we just print age of person. This is a age, correct? So look here, this is an interface declared with the fields, and this interface is assigned to the variable as a type, and then values are assigned and these values are printed. So it is the, you can say you are duck typing interface for a type, correct? Now just compile the program. So this is TSC and this is the interface table. Let's compile it. So it is a node and then interface table.js. Okay, sorry, this is not saved. Yes, look here. It's great. Name of the person is John, age of the person is 25. So here we assigned interface as a type. Okay. So this is example for interface as a type. Now let's see the example for the interface as an array. So I declare an interface as a list, and here I define the array and the index of the array. Suppose I want to define as a number. By default it is number, but the data I want to define as a string. Okay. Now I want to assign that interface to the variable. So suppose this is my array list, and then I want to assign it as a interface list. So here just go with the square bracket, and you define your data. Yes. So suppose I define the first name as A, second name a string as B, third name as a C. Okay. And after that, suppose I define with a number as an index. So this is suppose a D. Okay, and then I will try to print it. So this is the array list, correct? Just save this. So here, look here, ABC, these are the values to the array list, and array list is a type of list where the index is a number. Okay, and after assigning 3 value, directly assign the 6th value, but the index is number and data is of a type string. So here it is also string, it is not a numbers. And then just try to compile it, save the program and try to compile it. Look here, so A, B, C, after that the empty string, empty string, empty string, and at the end of the last 6th index the D is added. So it is a valid data, correct? Let's see the example on function as an interface as an function type. So I declare an interface for a type function, and here I give the prototype structure for a function. Suppose key is a type of number, so one parameter, and value, suppose I give a type of string, and the function return type should be suppose a void. So I set one rule for function. Function should have 2 parameters, key and value, and return type should be the void. Now I declare one function, for example f1, and here I define the key of a number and data as a string, and return type should be 1, right? And then here I just print console.log, and I want to print the data as key, and so I want to print for it data. Okay, then I define another function, that is f2, but I want to change the parameters. Suppose now it is a key number and the return type is void, but it takes only one parameter, and then console.log, I just print the value key. Okay, now 2 functions are available, and now I want to assign interface as a type. So I declare a variable is a variable of type temp, and I assign that is a interface, and this should assign with the function f1. Okay, and then I call it temp comma previous. Okay, now let's check, compile the program. Just compile it. Sorry, this is with TS. Look here, 10 and ABC is printed. Now which function gets called? F1. Now suppose I try to assign temp is equal to F2, okay, and I try to call temp step. Now look here, it is showing me error. That is, the temp should contains the TF, then number and string, and return type should be void. But our F1, F2 function, which takes only number, so this call is not possible, and F2 is not a type of TF. Okay, so here we are just applying the rule of interface function to the F1. Yes, so F1 should follow the rules which is given by the interface TF. So function interface as a function type you can do in this way. Okay, example, how to implement the interface. So I declare the interface iPerson, and here I define the field of a name, and I define a simple method display, and the return type is suppose what. Okay, then I define an interface of the employee, and here suppose I define salary as a number. Okay, now I define a class test interface. Suppose here I implement the iPerson and iEmployee. Now when you implement the interface, so in a TypeScript we can define the fields inside the interface. That's why when we implement the interface we have to override this, so we have to define it here again. So the string, if you not define it gives error, and then salary, right? And that is from number, and here now you define the constructor, that is name, of a type string, and then salary of a type number. Okay, and now you have to initialize it, and now this name is instance variable, and you have to assign this using this compulsory, this keyword salary is equal to salary. Okay, and now again it is showing error. So what is remained? Just class interface incorrectly implemented iPerson, property display is missing, correct? So here you have to write a display function. So display, and the type is void. So here have the parenthesis, and then you simply write the console.log, here name of person is this dot name. This dot, right? Simply copy this. In a TypeScript, semicolon, the last termination semicolon is optional, so you write or don't write, doesn't matter. Now here what you have to do, this is the salary, this dot salary. Okay, and now outside the class you just test it. So variable test p and it is of type person, but you have to create a object of test interface, correct? And here you have to pass the 101 comma sorry, first is name. So suppose a John, and here I pass something like this. Okay, so I person is not there. I think it is okay. It is I person. Yes, and here you go like this. Test p dot display. So definitely it will call. Now suppose I try to do like this, variable test employee colon, then I go like this, employee is equal to new test interface, and here I pass another mark, and suppose this is 60,000. Now it is okay, but if I call test e dot display, now check here, so it is not showing me any intelligence, so it gives me error. Why? Because I employee is not having a display, test interface having a display, but here we are making a reference of super type and interface type and object of the subtype, that is the class who implemented your interface. But in an employee there is no display. That's why in upcasting, this is upcasting. In upcasting always you have to follow whatever the members are available of your super type, only that you can call with the objects. Okay, otherwise it gives you error. So it is a same rule applicable here, and in upcasting you don't do this. Otherwise you simply, how to do this, test interface, so it will remove the error. Okay, now just compile it. Just look here, name of the person John, salary is 50,000, mark 60,000. Okay, so if you have any doubt, you just make a comment. If